Hi, folks. Welcome back to 3.2, and we are in part 3. We're talking this time about the factored form of the quadratic function, okay? So the factored form of the quadratic function looks something like this. We're going to have a binomial times another binomial, okay? And A, B, C, and D, all of these lowercase letters, they're just numbers. They're just numbers. That's it. Okay, so it could be like 3x plus 2 times x minus 1 or something like that, all right? Now, the factored form of the quadratic function is most useful for finding x-intercepts, okay? So the very thing that was so hard for us to do in the previous one in vertex form is actually much easier to do in factored form, all right? It is least useful for, I think, finding the vertex. Okay, so finding the vertex is actually a little bit harder. So the nice thing about having all these different forms is sometimes we're able to find things more easily, and sometimes we have to do a little bit of work, but altogether it helps us practice so many algebraic tricks and procedures, okay? All right, let's move on to an example. These examples are long, they take up a whole page. That's why there's so much extra space in there. All right, well, here's what we are going to do. The first thing we're going to do, all right, is actually to go ahead and find the x-intercepts. All right, this is going to be the first thing that we do here. Now, in order to find the x-intercepts, we know that it's a number, comma, 0, or the y is equal to 0. We're going to grab our equation, x plus 2 times x minus 5, and set it equal to 0. X plus 2, x minus 5. Okay? Now, each one of these, x plus 2 equals 0, x minus 5 equals 0, we really get x equals -2 and x equals 5, all right? But we want to write them as coordinates, -2 comma 0 and 5 comma 0. So these are our x-intercepts, and we can go ahead and draw them right on our graph. So -2 comma 0, and then 1, 2, 3, 4, 5 comma 0. Okay. All right, now that we've done that, my suggestion is to go ahead and find the y-intercept, all right? And then we'll go from there. So to find the y-intercept, it's plug in 0 for x and get a number out, all right? So y equals 0 plus 2 times 0 minus 5. That gives us 2 times -5, or -10. But we want to write this as a coordinate, so we're going to write 0 comma -10. And we can go ahead and graph this y-intercept on our graph. So 0, -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now, we found our x and y intercepts, okay? The next thing we're going to do is we're actually going to determine the coordinates of the vertex. That's going to help us figure out what our middle line in the table should be, okay? So here's how we're going to find the vertex. We're going to take our x plus 2 times x minus 5, and we're going to go ahead and FOIL it out, or we're going to distribute everything. That gives us x squared. Let's see, -5x plus 2x is -3x minus 10. Okay, so we FOIL everything out. After we FOIL, we're going to put it in some of the values into a formula. And that formula is going to give us the x value of the vertex. Okay, so to find the x value of the vertex, we let x equal negative b over 2a. All right. Now, some of us might be like, what's b? What's a? Those are good questions. A is 1 in this case because we have a 1 in front of the x squared. B is negative 3 because that's the number in front of x. And C is negative 10 because that is the number that has no variable with it. Okay, so we take our B and we say negative B over 2 times A, and that gives us 3 over 2. Okay, 3 over 2. That means the x value of the vertex is 3 over 2. Okay. Now, to find the y value of the vertex. All right, to find the y value of the vertex, we take this x that we just found and we plug it into the formula. And it doesn't matter if you plug it into the original or the FOILed out one. Okay, I'm going to go ahead and plug it into the original one. And let's see what we get. Y equals 3 halves plus 2 times 3 halves minus 5. All right. See, 3 halves plus 4 halves is 7 halves. 3 halves minus 10 halves is negative 7 halves. And so this gives us negative 49 over 2. All right. So this value right here, all right, is a pretty big number, and that's okay. Sometimes not everything is going to fit on our graph perfectly, okay? So we sketched what we can. We have our vertex here, which let's write the full coordinate as 3 halves, comma, negative 49 over, sorry, that should be 49 over 4. This is 2, this is 2. 2 times 2 is 4. All right, so 49 divided by 4. And that's going to be just off the grid. It's about 12, a little bit less than or more than negative 12. Okay, so that means that at 1.5, which is about here, all right, about 1.5, we're going to have a y value of negative 12.25, which is going to be just down here somewhere. Okay. Now, if I put in if I put in 3 halves and negative 49 over 4, okay, let's pick some numbers that are around 3 halves. So 3 halves is like 1.5. So going bigger, I could have 2, 3, 4. And then going back down, I could have 1, 0, negative 1. Okay. But either way, this is the coordinate of our vertex. And since I have the coordinate of the vertex, I can actually go ahead and find the axis of symmetry equation. It's just going to be x equals 3 halves, or x equals the x value of the vertex. Okay. All right, let's plug in some numbers. Let's see what we get. If I plug 2 into here, I get 4 times negative 3, which is negative 12. All right, so let's see. negative 12. And that should be the same as on the other side, negative 12. All right, let's plug in 3 and see what happens. 3 plus 2 is 5. 5 times negative 2 is negative 10. And this is negative 10. Cool. All right, we plug in 4. We get 4 plus 2 is 6. 6 times negative 1 is negative 6. And negative 6. All right, let's plot these points, see what we get. Negative 1, 1, 2, 3, 4, 5, 6. Negative 10, there's actually a negative 12 somewhere here. Negative 12. And then at 3, I'm at negative 10 again. And at 4, I'm at negative 6. All right, so off the grid a little bit, but we've got our parabola right here. All right, and now we can finish off with our domain and range. Domain, negative infinity to positive infinity. Range, I'm starting at negative 49 over 4, and I'm going up to positive infinity. Okay, so let's get this all on one page for us. And we can see that we've got all of this worked out for a factored form. All right, let's take a look at one more example. All right, so we've got this time negative x minus 1 times x minus 7. So we first are going to, let's plot our steps here. We're first going to find the x-intercepts. Then we're going to find the y-intercepts. Then we're going to find the coordinate of the vertex. That will allow us to determine the equation for the axis of symmetry. Once we've got all that, we can plot our table, plot our graph, determine our domain, and determine our range. Okay, so just to zoom out, we're going to start with 1, 2, 3, 4, 5, 6, 7, and 8. Okay. All right, let's begin. We're going to find the x-intercepts. We take our equation, set it equal to 0. Negative x minus 1, x minus 7. Let's make sure I copied that down right. I did. Okay. That means that x can equal 1 or x can be 7. That doesn't get us full credit though. We need to write them as coordinates. 1, 0, and 7, 0. And these would be the y-intercepts, or the x-intercepts on the graph. So 1, 2, 3, 4, 5, 6, 7. Those are my y-intercepts. Sorry, x-intercepts. Okay. Now we're going to find the y-intercept. We're going to plug in 0 for x. So y equals negative 0 minus 1 times 0 minus 7, which is negative 1 times negative 7 is negative 7. Again, that's not full credit. We need to write it as a coordinate. 0, negative 7. This is our y-intercept. One, 2, 3, 4, 5, 6, 7. All right. So we've got our x-intercepts, we've got our y-intercept. Now we do the hard work to find the coordinate of the vertex. And the way we do that is we start by foiling out what we have. And just like before, I'm going to suggest that we multiply these out first, and then we distribute that negative sign. Okay, so let's distribute that or multiply those first. We get x squared minus 7x minus 1x is minus 8x. Negative 1 times negative 7 is plus 7. And I distribute that minus sign now. I get negative x squared plus 8x minus 7. And I'm going to take a moment here to write down what my A and my B and my C are. Okay, so A is negative 1, B is 8, and C is negative 7. And in order to find the x coordinate of your vertex, we say negative b over 2a, which is 8 over negative 8 over 2 times negative 1. So that's negative 8 divided by negative 2, which is a positive 4. Much nicer than the previous problem, right? But now we're going to take this 4, we're going to plug it back into one of these equations. Now I'm going to go ahead and plug it back into the original, all right? So y equals negative 4 minus 1 times 4 minus 7, which gives negative 3 times negative 3, which is 9, okay? But we don't want to leave it like this. Our vertex is 4, 9. All right, 4, 9 for our vertex, which means that the equation for the axis of symmetry is x equals 4. All right. Let's go ahead in the middle line, 1, 2, 3. In this middle line, let's write the coordinates of our vertex. So we had 4, 9, right? And let's go ahead and plot that too. 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this graph is coming along pretty nicely. Okay, so now we want to count up from 4, so 5, 6, 7, and we want to count down from 4, 3, 2, 1. Okay. All right, I'm going to go ahead and plug in 5 in for x. So 5 minus 1 is 4. And then 5 minus 7 is negative 2. So I end up with 8 here, and I should end up with 8 on the other side as well. So 8 and 8. All right, I plug in 6. Let's see what I get. 6 minus 1 is 5. And 6 minus negative 1 is, or 6 minus 7 is negative 1. Negative 1 times negative 5 is 5. All right, so 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now, if I plug in 1, I'm going to get 0. If I plug in 7, I'm going to get 0. And turns out I already have those points here. And so I can, at this point, go ahead and connect everything that I have. All right, we've got our graph. Home stretch here. Domain is every real number from negative infinity to positive infinity. And the range, well, I actually start as low as negative infinity, but there's a cap on how high I go. That cap in this case is 9. So we have a 9 at the right end, and we use a bracket to show that we're including 9 as a value. Okay? Let's zoom on out so we can see this whole question on one page. And that, my friends, is it for the third part of this video. Come on back to hear what we're going to do with standard form.